Battery reliability testing frequently specifies a temperature uniformity of plus or minus 0.5 degrees Celsius. Can half a degree really make that much difference? Can you quantify that with some real data?
The results are quite striking. We conducted comparative testing using battery cells from the same production batch. One group was tested in a chamber with plus or minus 0.5 degrees Celsius temperature uniformity. The other group was tested under plus or minus 2 degrees Celsius uniformity. Both groups completed 1,000 charge-discharge cycles at 45 degrees Celsius and 1 C.
The results were striking.
The first group still retained 92 of its original capacity after 1,000 cycles. The second group dropped to 85% after only around 800 cycles. Post-test analysis revealed severe lithium plating on cells located near the cooler airflow, while cells exposed to warmer regions suffered accelerated separator aging.
In practical terms, a seemingly small 2 degrees Celsius temperature difference for an electric vehicle shortened battery life by approximately 200 charge-discharge cycles. That could represent the difference between roughly 30,000 kilometers and 50,000 kilometers of service life.
Exactly. That's why leading battery manufacturers now specify environmental chambers with temperature uniformity better than 1 degree Celsius, or even as tight as plus or minus 0.5 degrees Celsius, and temperature fluctuation no greater than plus or minus 0.3 degrees Celsius.
These specifications aren't about pushing technical limits for their own sake. They're about ensuring that engineers can accurately detect the battery's true degradation.